Okay, we're going to do another example of finding the derivative function or instantaneous rate of change of a function at a given x value. So we're actually going to find the derivative function and we're going to find the slope of the tangent line given a function. So here we have our function. We're going to set it up using the difference quotient. We're still using the difference quotient. Here's the difference quotient. So this says x squared, so x plus h squared plus 2, subtract the original function all over h, and then we're going to expand. Remember what x plus h squared is. It is x squared plus 2x, h plus h squared. You need to remember to add on that plus 2. Whoops. Right there. And then you're going to subtract that function. Whoops. So subtract x squared and subtract 2. All right. And now you're going to cancel what they have in common. Or, you're going to cancel what cancels out. So you have a positive x squared and a negative x squared. Those cancel. You have a positive 2 and a negative 2. Those cancel. And then this over h is all you have left. Which is what we have right here. And then they all have an h in common. So we're going to factor out the h. This one will cancel. One of those will cancel. This will cancel to 1. So you pull that out. The h's cancel. And now what you have is dy over dx, because that indicates derivative, is equal to the limit as h approaches 0, 2x plus h, and now you can substitute in 0, leaving 2x. So the derivative function, and notice the limit now can go away because we did the limit process to find what dy dx equals. It equals 2x, and now we're going to plug in that negative 1 for x, because that's what it says to do at that given point. So 2 times negative 1 is negative 2. That's the slope of the tangent line. Okay, they get more complex than this. For example, if you are given this function right here, 3x to the 4th minus 5, that would be terrible because this is x to the 4th, so that's going to be 3 x plus h to the 4th. Well, then that's going to expand to 3 x to the 4th. I'm just going to leave a 3 on the outside so I'm not having to write it. Then that's going to be 4 x to the 3rd h plus 6 x squared h squared plus 4 xh cubed, really should have parentheses around those, plus 1 h to the 4th. And then it's 3 times all of that. And then remember, you have to subtract 5. Then you have to subtract that entire original function. And all of this is over h. And then you simplify, you cancel, you rewrite, you factor, you do all that stuff. So, and then you end up with what dy dx is equal to, and then you plug in the given x value to find the slope of the tangent line. It gets more complex, but hopefully whatever professor or teacher you have, they won't do one that's too terribly hard. All right.